right, hey guys, today we're going to look at writing systems and graphing to solve those. So let's see what we have here. So it says one satellite radio service charges $10 per month plus an activation fee of $20. The second service charges $11 per month plus an activation fee of $15. The information is given in the tables below. So what we're going to do is actually write an equation for, let's start with the radio service 1. So this would be y equals, because we wanted an mx plus b, so our m is 10 and the b would be 20, given the information here. So this would be y equals 10x plus 20. While the other one would be, again, the m is 11. The b is from up here, which would be 15. So here we go, y equals 11x plus 15. So these are our two equations. All right, now we're going to use these two equations and we're actually going to graph them to see in what month will the cost of services be the same. So here we go. So let's graph these equations. So we have y equals 10x plus, I don't know why my caps lock is on, but it's okay, it should work just fine. There's the first one, and then we have y equals 11x plus 15. So in this case, we're gonna have to zoom out to see where they actually intersect, which is gonna be a little tricky. It looks like it's almost impossible. Let's see, maybe right here. Looks like that's about right. So it looks like it would be 570 would be the point where they intersect. So it would be the 5th month and $70. So let's check this actually before we move on. So if I go to my calculator, let's see, let's do 10 times 5 plus 20. Plus 20 would be great. Plus 20. There's our $70. Now I'm going to do the same thing here. 11 times 5 plus 15. And it is also $70. So you can see here that month 5 would be when both services cost the same. All right, so in this case, it says you have 100 coins worth $6.95. All of the coins are nickels and dimes. How many nickels and how many dimes do you have? Write a system to represent the situation. So there's a couple of things we have to do here. We have to designate that, I'm going to say nickels are X and dimes are Y. And if you notice, it talks about worth and total. So our two equations are going to be the worth, what they're worth, and then total number of coins. So a nickel is worth 5 cents. So that would be 0.05, while a dime is 10 cents, so 0.10. So when we write our equation for the worth of the nickels, that would be 0.05x plus, I'm going to put a 0 there so the signs aren't right next to each other. I guess I technically should have put a 0, here as well, but it's too close to that. And then it has a total value of $6.95. Now, the same thing with the total. This is one that happens a lot where we're like, what is the other equation? Well, it's x plus y equals 100. So now we have our two equations that we can actually graph. So let's see what we have here. I'm going to, so we have 0.05, maybe. 0 0.05x plus 0.10y equals $6.95. Something's not right here. Why is it giving me an error message? Maybe I should go back to lowercase. I'm sorry about this. There we go. I guess that was the difference. So then we have x plus y equals 100, because that's how many coins we have. Whoops. Now, of course, we're going to have to zoom out to find our graph. So we can see this point of intersection is right here. So when I touch that, should give me the point 61 and 39. So 61, 39. So that means we have 61 nickels and 39 dimes. And of course, we can check that by substituting those values into both equations. So if I have 0.05, not 65, times the number of nickels, which is 61, plus 0.10 times the number of dimes, which is 39, that's $6.95. And then, of course, 61 plus 39 should give us a total of 100, and it does. So that means those two values satisfy both of those equations. I'm going to look at a little bit of vocabulary. So when we have something that's inconsistent, it makes somewhat sense that it would be no solution, because inconsistency means it's not going to happen. Now, consistent and dependent, we would look at this as being infinitely many. So there are solutions, and it depends on where those lines fall. Now, the consistent independent would be where we have exactly one solution, just like we did on all those examples we just did.